Okay, now, so this particular session, so we'll be discussing about the block diagram of a special type of radar called as an MTI radar. So when I tell MTI radar, now this MTI stands for moving target indicator. MTI stands for moving target indicator. Now this particular radar is used to identify the moving target. As the name indicates that this is a moving target indicator, so therefore this radar is used to detect the moving targets there. If there is any target which is in motion in the locality or in the area of my observance, if any moment is found or if any moment is identified, now that particular moment is identified or detected with the help of one particular type of radar, so that is called as an MTI radar. This is a special type of radar which is basically designed to identify the moving targets here. Okay, now in this particular radar, so first we'll try to discuss the block diagram, and after that maybe we'll try to discuss on what are the advantages and disadvantages of this particular radar there. Okay, now so the operation of this particular MTI radar, so the main part of this particular radar is that it has got two oscillators. One is called as TALO and other one is called as COHO. Now STALO stands for stable local oscillator and COHO stands for coherent oscillator. So we have got two oscillators in that. One is called as STALO, so it stands for a stable local oscillator. COHO, which is an coherent oscillator there. Okay, now so we'll go for the working of this particular radar there. The first, the operation of the radar will start from this stable oscillator. Now this stable oscillator, it will generate the oscillation, it will produce the oscillation and it will produce the frequency of F naught. Now, once the particular frequency is produced, now these frequencies given to two sections. One it is given to mixer 2, the other one it is given to mixer 1. So, at the same time, COHO will also produce an frequency, and that particular frequency we call it as an coherent frequency. So, stable oscillator is produced on frequency called as F naught. Coherent oscillator is produced on frequency called as an FC. Now, these two frequencies are given to mixer 2. Given to mixer 2. Now when you speak about the mixer, so in the previous sessions we said that mixer either it can add these two signals or it can subtract these two signals there. So in this case we are adding these two signals. What are these two signals? F0 plus Fc. So the mixer 2 will add these two signals F0 and Fc, and the output of the mixer is given to a klystron amplifier. Now this klystron amplifier, it's a type of a microwave amplifier. So why are we using klystron amplifier? So because in the radar we will make use of a microwave signal. So therefore the amplifiers what we use should also be an microwave amplifier. So therefore klystron is a type of microwave amplifier which is used to amplify the microwave signals there. Along with the amplification, we also go for a modulation. So what you do here is we amplify and modulate the signals and we get the signal as F0 plus Fc. Now that will give it to an duplexer. So duplexer, we all know that it's a bidirectional switch which will decide whether the antenna has to be connected to the transmitter or it has to be connected to the receiver. So now at the beginning of the operation, the duplexer will connect the antenna to the transmitter now. So whatever the signals we have produced, now these signals will come to the antenna and it is escaped into the signal in the space. So what is the signals we are transmitting now? The transmitted signals is F0 plus Fc. Now these signals will travel in space. If there is no object identified, then these signals will never return back. If at all there is an object identified, now these signals will come back. Now the duplexer which is acting as an antenna, so this particular duplexer will remove the antenna from the transmitter and it will connect to the receiver. So you can see that the received signal is once again F0 plus Fc. The transmitted frequency was F0 plus Fc. The received signal is also F0 plus Fc. Now what I'll do, I'll give this to a mixer where one input is F0 plus Fc, the other input is F naught, which is the frequency we generated from shallow oscillator. Now these we have got another mixer here. So the job of the mixer is either it will add the signals or it will subtract the signals. So here what we do, mixer 1, it will subtract these two signals, F naught plus FC minus F naught. So now what will happen, F naught and F naught will get cancelled, and that I'll get an FC. Now, so since we have with this particular frequency, we'll amplify that with the help of an IF amplifier. With the help of the IF amplifier, we'll amplify that, and output of that we give it to an phase sensitive detector. Now, what this phase sensitive detector will do? So it will compare the transmitted frequency, because FC was the frequency which we generated and then we transmitted from this particular path. We are also getting an FC which has been reflected from the target. So we have got two FCs here. One FC which was transmitted, we are keeping that for your reference. And we have got another FC which has been reflected back from the target. Now what this particular the phase sensitive detector will do, it will check if there is any phase difference between the transmitted coherent frequency and received coherent frequency. Okay, now, so what will happen is, we'll not come to know that in one calculation. So therefore what we do is, so that phase difference we'll keep it as it is and amplify with the help of an amplifier, and we'll produce a phase delay. We'll produce a delay of time t is equal to 1 by PRF. What is PRF? PRS is your pulse repeating frequency, and again try to check the what is the phase difference between F0 and FC, and this difference will amplify with the help of an amplifier 1. So these two signals are subtracted. If at all if there is any difference between these two, the subtractor will give you one value. So the value whatever we are giving here, that is given to an indicator. Indicator will be a display device which will display only a number. Now, suppose take for example, if there is no phase difference between the output of amplifier 2 and amplifier 1, then the subtractor output will be difference of these two, the subtractor output will be 0, and the indicator will show it as a 0. When the indicator shows it as a 0, it indicates that this particular radar has not detected any moving target. Suppose if there is a moving target, and we have discussed that whenever there is that relative motion between the source or an observer, there will be a changing frequency or change in the wavelength. So therefore what will happen there will be a change between the transmitted frequency and the received frequency. Now that particular change is identified here, and it is, we waited for one after delay line of t is equal to 1 by pi rf, and we found that there will be a change in phase shift, and that we subtract with the help of a subtractor, and we get one particular value, and they will come to know that okay, there was one moving target and our radar has identified the moving target. So this is how the radar will identify the moving target. Now maybe I can show you a graph there. Okay, now so this is the signal what I am getting from the first signal, and this is the signal I got after second pulse there. Now when I compare these two signals, so you can see that there is no change. Transmitted and received, the phase shift is almost no change. So there is no moving target. So there is no change between that, there is no moving target. Now when you compare these two, there is a change between these two signals. When I compare these two, there is a change. Then once again, when I compare these two, there is a change. When I compare these two, there is a change. When I compare these two, there is a change. When I compare these two now you can see that there is a change. When I compare these two, they will see that there is a change. Now F is the output of an what you call this is the given to a subtractor. Now the subtractor, it identifies that there is a difference between the pulse what I have received and there is and the pulse what I am receiving after 1 by PRF. So this particular difference is given to a subtractor. The output of the subtractor will give it a number, and that particular number will give you the velocity of the moving target. The number what we get, the output of this particular radar, I said that it will be only one number. And what is that number? Now that number is the velocity of a moving target. So when you look into this first two waveform, this is the waveform what I received, and after PRF, this is the second waveform. So there is no difference. So the radar, the output of the radar will be zero. Compare these two, there is a slight difference. Compare these two, there is a slight difference. When I compare this, so the difference is increasing. So the output of the subtractor will give you one value, and that particular value will be velocity of a radar. So when I go back to the plot diagram, so this is what happened there. So the signal of amplifier 2 and the signal of amplifier 1. Whenever there is a change in the phase shift, so that is identified, and the subtractor will produce the output, and the output of this particular radar will be one number, and that particular number is nothing but the velocity of a moving target. So we have this radar has identified the moving target, and it is also giving the velocity of the moving target. So that is this particular radar finds an application where we are trying to find out the moving target, and we are interested in the velocity of that particular moving target. So maybe but the drawback of this particular radar is that this radar will not give you the indicate, and will not give any information about at what distance the target is identified. This radar will only identify the target, but it will not tell you at what distance the target is been identified, and it will also not give you any information about the size of the target, and it will also not give you any information about whether the target is approaching towards the radar or the target is moving away from the radar. So simply what it will do is it will identify the moving target, and it will give the velocity of that particular moving target. Now this is the working principle of an MTI radar, and this MTI radar stands for moving target indicator. Moving target indicator radar. So I hope you have understood the working block diagram and the working principle of an moving MTI radar.